So the question is, how do we find the vertical asymptotes for a rational function, right? So if fx equals nx over dx, right, is a rational function, such that nx and dx have no common factors, and if a is a zero of dx, then the line x equals a is a vertical asymptote of the function fx. Okay, so basically what we're saying is, if there are no common factors, when we factor the numerator and the denominator, if they have no common factors, then all the zeros of the denominator will be vertical asymptotes for the function. So let's take an example. So in this example, what we want to do is we want to find the vertical asymptotes for the functions fx equals x squared minus 4 over x squared minus 9, and then fx equals x minus 3 over x squared minus 9. So let's look at this function. The first thing you want to do when you're trying to find vertical asymptotes is go ahead and factor the function if possible, right? So I'm going to go ahead and factor the function, and I can write this as x minus 2, x plus 2, right? Because this is a difference of two squares. And again, the denominator itself is a difference of two squares, so I can write that as x minus 3 times x plus 3. Now we note that the numerator and the denominator have nothing in common, right? There are no common factors, so my vertical asymptotes for this function are the lines x equals 3 and x equals negative 3. Okay? Now let's look at our second function. So let's go ahead and factor again. So the numerator is already in factored form, so this is x minus 3. And the denominator, I can factor it as x minus 3 and x plus 3. Notice now that the numerator and denominator have factor in common. So if I cancel them off, basically what I get is 1 over x plus 3. So in this case, the line x equal to 3, right, will not be a vertical asymptote, even though 3 is a 0 of the denominator, because it cancels off with the numerator. But x equal to negative 3, this will still give me a vertical asymptote. So here my vertical asymptote is going to be the line x equals negative 3.